Hello and welcome to another LeetCode problem. Today we're going to be continuing on with the JavaScript challenge and doing chunk array. And I actually skipped ahead a few problems because the one we're going to do today originally is going to be a little bit longer, and so I'm going to do that in a day or two. But we're going to do this one today. And so for this problem, you're given an array R and a chunk size, and you want to return a chunked array. A chunked array contains the original elements in R but consists of subarrays, each of length size. The length of the last subarray may be less than size if array length is not evenly divisible by size. You may assume that the array is the output of json.parse. In other words, it is valid JSON. Please solve it without using Lodash's chunk function. Okay, so let's take a look at some of these. So for the first example, we have an array of length 5 elements and the size is 1. So we want to split it up into 5 subarrays of size 1. Then for the second example, we have size 3, but the length of the subarray is 5. So what we're going to want to do is we're going to want to have 2 subarrays. One's going to be length 3, one's going to be length 2. And then the third example is the size is 6, and there's 5 elements, so we're just going to put all those elements into a subarray. And for the last one, we have an empty array, and so we just return an empty array. So I'm going to show you 2 ways we can do this, and I think no matter what way you do this, the time and space complexity should be pretty similar, but let's just get into it. So one thing we can obviously do is we can just make an array and we can keep adding elements to it. And once that's length size, we can just push that into our new array, right? So it's going to be something like this. We're going to make an array for our output, and we're going to make an array for our chunk. And what we're going to do is we're just going to loop through the original array. So and we're going to say if the length of the chunk is the size, then let's push that into the result. Otherwise, let's keep adding to the chunk, right? So this is equal. Let's push that into the result. Chunk. And then when we push that into the result, we can reset our chunk, right? So okay. And otherwise, let's just add to the chunk, right? So okay, and then let's not forget that we might have a chunk left over, right? Like in this example here. So if we push these first 3 elements and then we have a chunk left over, we need to actually make sure that we push the chunk into the array at the very end. So we can just say if chunk length, let's push that into the result as well, right? So okay, now finally we have our whole result and we can return the result. Well, let's take a look. 135. What stupid thing did I do? Let's find out. Oh, right. So we want to be doing this after we push the item into the chunk, right? So we want to be putting the item into the chunk first, then we want to check for the chunk length. Yeah, so we need to rearrange this a little bit. And it needs to be, this needs to go in here. Because we're essentially not pushing items into the chunk. Okay, so we're going to push the chunk, we're going to push the item into the chunk, then we are going to reset the chunk afterwards. Okay, that should be it. And let me just put this here, make sure these line up. Okay. Okay, nice. So that does work. Now, what's another way we can do this? Well, we could do it this way. There's a bunch of ways you could do it, but they essentially end up being the same thing. So another way I'm going to show you is we're going to delete this, and we're not going to have a chunk anymore, but instead we're going to do slicing. And so slicing, just like Python, you just give, the way slicing works, right? So if you do slice, it takes a start and a stop. And the way it works is it will be all the values from the start up to but not including the stop value. And so what we can actually do is we can just have an index. So we can just say, like, let's make an index equal to 0, and let's just keep slicing chunks of the array until we're out of bounds, and let's keep adding those chunks into the result. So we can say something like while index is less than r.length. Let's just keep making slices, right? So res.push, then we can say r.slice. And so if we start at the index, if we start at the index, how big of a slice do we want? So it's actually going to be index plus size, I believe. And essentially what this is going to happen, like let's say size is 2 and we start at index 0. Then you would have something like 0 to 2. You'd have a slice of 0 to 2. And essentially 0 to 2 means let's take the 0 element, let's take the 1 element, but let's not take the 2 element. And so that's going to be a slice of 2. And so once we push this slice in, then we need to update our index. And so our new index is going to be index plus size. Okay, so we're going to keep doing this, and then we're going to finally return the result. And by the way, one thing about slicing is, let's say you have an array like this. Let's say you have an array like this, right? So 1, 9, 6, 3, 2. So I think one or both of your slices can actually be out of bounds, and it will still give you a valid thing. So definitely the second one can be out of bounds. So you could do something like this. So you could do something like array slice, let's say 2, and this can be like 100. And then essentially what this will do is, since you're out of bounds here, it will only slice, you know, this section here, just like in Python. So that's quite useful, because then like your slice can be out of bounds and it'll still work. Okay, and so now we're gonna try this method. All right, and that works too. And I think for all of these, if you want to talk about complexity real quick, so the time complexity is going to be O of n, but the space complexity is actually going to be O of the slice, because regardless of what way you use, so when you make a slice in Python and in JavaScript, you're essentially creating like a new array, and then you're pushing that into the result, but then it gets deleted. So you make it, you push it into the result, but then it gets deleted afterwards. But you're still making a slice, like, so every time you make a slice, and so the space complexity is you're making a slice every time, and so that's why it would be O of a slice for this, or for the push method as well, like when you make chunks, because you're gonna have a chunk amount of elements in your chunk, and so whatever, you know, or this is gonna be O of size, I guess, but that's gonna be the space complexity if you're not counting your output. If you're counting your output as space, then it's going to be O of n, like if you're counting this as a space, because then you're going to be putting the whole array into the result. But if you're not, then you're going to be holding a chunk at a time, which is length size. All right, so it's going to be it for this problem, quite a short problem, and I will do the matrix problem tomorrow. And if you like this video, then please like it and subscribe to the channel, and I will see you in the next one. Thanks for watching.